Welcome back as we look at some more polynomial division. The previous video we looked at the remainder theorem, and we did some polynomial division, and we found that if we had a polynomial f and we divided that polynomial by the linear factor x minus a, then I see I had a spelling error, then the remainder number r, when the division was completed, was the same thing as evaluating polynomial f at number a. So division of polynomials is related to evaluating a polynomial. If you divide by x minus a, the remainder is the same as f evaluated at a. Okay. Now let's say the remainder is a number 0. Well, that's nice. That means the division has come out evenly, no remainder. And that brings us to the factor theorem. So if we evaluate a function at a number a and we get 0, from the last theorem, that's telling us the remainder r from polynomial division would have been 0. A remainder r means division comes out evenly, so if f of a is 0, then x minus a is a factor of the polynomial. So a polynomial f of x has a factor x minus a if and only if f evaluated at a is exactly 0. Okay. And to show an example of this, let's show that x minus 1/2 is a factor of polynomial f of x, this cubic. And once we show that the division would come out evenly, let's go ahead and factor that polynomial completely. Okay, so first step, we want to show x minus 1/2 is a factor. So that means a is positive 1/2, and we want to evaluate polynomial f at 1/2. Okay, so we need 2 times 1/2 cubed plus 1/2 squared minus 13 times 1/2 plus 6. 2 times 1/2 cubed plus 1/2 squared minus 13 times 1/2 plus 6. So we simplify our exponents first, and we get 2 times 1/8 plus the fraction 1/4. We can multiply and we'll get minus 13/2, and we still need to add 6. And multiplying here, we'll get 2/8, which will reduce. And adding 2/4 will give us 1/2. And 1/2 minus 13/2 is negative 12/2. And I think we have negative 6 plus 6, 0. Okay, that means x minus 1/2 divides f of x without a remainder. This is, excuse me, I was off the charts. This means that x minus 1/2 is a factor of f of x. Alright, so let's get this polynomial written down again so that we have it at hand. So our original polynomial can be factored. Let's put that up off the screen. And we know that x minus 1/2 is a factor. What are the other factors in the factorization of the original? Okay, well, we could do long division. We could take our dividend, the cubic, and our divisor, but we can also do synthetic division. Instead of x minus 1/2 being written down, we write down positive 1/2. We take those coefficients from that polynomial, 2, an understood 1, that negative 13, and a 6. We make sure there's no missing terms as we decrease in powers. And we know how the synthetic division goes. We bring down the leading coefficient, and we multiply a times that number. 1/2 times 2 would be 1. We add in the next column. Again, 1/2 times 2 would be 1. We add in this column, get a negative 12. 1/2 times negative 12 is negative 6. And we knew our remainder would be 0. We just didn't know what the quotient would be. Okay. So now we have more information. Not only is x minus 1/2 a factor, but constant linear quadratic 2x squared plus 2x minus 12 is a factor. Now we'd like to know if that's a prime factor, or if this quadratic might also factor into linear factors. I notice there's this greatest common factor of 2 that I can pull out of the parentheses. And now this quadratic looks familiar. And you know what? I will probably pull this coefficient out front. So we have 2 times x minus 1/2. And then this quadratic, we look at the factors of negative 6. That'll add up and give us positive 1. So I think that's 3 and negative 2. Okay. So we had this quadratic polynomial that it did indeed factor. Okay. Now some textbooks would leave maybe this factorization written this way. Other textbooks, trying to get integer zeros or integer values here, might distribute that 2 back through the first set of parentheses. Okay, but that completes our example. Now a follow-up or a connection that's an important connection. For each one of these linear factors of f, there is an x-intercept associated with it, x-intercepts of the graph of f. So whereas 2x minus 1 equal to 0 at x equals 1/2 is an x-intercept. Would be written as 1/2 0. Associated with the linear factor x minus 2, x equals 2 would be a 0 of the polynomial. So it's another x-intercept of the graph. We would write it as an ordered pair, 2, 0. And finally, looking at this last linear factor, what a value of x makes this last factor 0? Well, a negative 3. And so negative 3 is an x-intercept, and that would be plotted negative 3, 0. Thanks for your attention.